thing going on?
I'm good.
Yeah?
Yeah.
You have to write an essay or something like that?
Yeah, I have to, for my final, I have to write my own what's it called? Syllabus.
Whoa,
Yeah.
what?
Dang.
It's like a project.
That's wild. Okay, that's cool.
Yeah, I guess.
Is it syllabus for like a mock class that you
Yeah.
teach or something? That's cool. That's cool. Do you know what the class subject would be?
It's similar music.
You want to steal my syllabus? Yeah, that's kidding. Yeah, so it's like a music. Like, what about music are you thinking about?
It's like a music history class.
Music history. Music history. That's cool. All right. You know what era of history do you want to do for the music history for your class?
Well, I really wanted to like center on like reggae and like ska.
Oh, dang, Reagan ska. That's cool.
Like,
That's
how
real
it's,
cool.
like, I guess progress and like change over.
Like all the different waves of ska and
Yeah.
stuff? Yeah. And I remember like, yeah, first, second, third wave, fourth wave ska. Jeez, yeah. The last thing I listened to that was ska was like Straight Light Manifesto and Real Big Fish and things like that. Or, you know, in Mexico too, a lot of ska bands. But anyways, that's cool. That's awesome. Are you gonna do like an international lens or just like in the US?
Well, I think I started off more international.
Okay.
And then I like focus more on like.
LA.
stuff.
LA specifically. Oh, that's sick. That's sick. That's cool. That's real cool. All right. Cool. Well, it's 12:31. We'll wait like 1 or 2 more minutes to see if Angel comes on in. But if not, that's okay. All right. Ella, how's your quarter going? How's the summer going? Good?
Pretty good.
Yeah? Is this the only class you're taking or are you taking other classes too?
This is my only one.
Is the only one? Oh, okay. Are you doing summer session 2 as well or no?
No.
Just one. Okay.
Oh, okay. Oh, so you're just coming after me for something you don't even know I say.
You said that.
Hey, don't say that. Who said that? And I always say that.
All right, we can go ahead and get started. Welcome everybody back to another wonderful edition of CSE 8A Intro to Programming in Python. Today we're going to be doing the final review again, right? We started off looking at the practice final that we had that's already out on EdStem. All of you should have already have access to it. All of you should have already started to look at those questions, try them out, right? Quiz yourself, things like that. And today we're just going to be continuing on that practice final. We'll go through all the problems. Or if you have any specific questions, again, I'm willing and able to help you out with any specific questions you may have on any topic for CSE 8A. Okay? So, before we begin, PA6 was due yesterday. Okay, PA6 was due yesterday or the day before? PA6 is already due, is what I'm trying to say. PA6 was already due. I think this is copy pasted from yesterday's. But PA6 was already due. So please make sure that you have that submitted, right? So we can go ahead and grade that for you and have it back to you as soon as possible. We're also having a paid interview opportunity. There's an interest form that you can click on right here if you go to the slides that are already posted. Also, an EdSTEM post was also sent out to you. But if you're interested, we'd love to give you, provide a 1-hour interview, right? A paid 1-hour interview with you, just to hear about your experience in the class, certain assignments that we submitted for you all to do, certain course material, things that we just want to get your experience, and that's it. Okay, so please, 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 if you'd like, there's a paid, and this is also optional. No need to do it. If you don't have time, or you don't want to, no need to, okay? Whether you participate or you don't participate in this interview will have 0 effect on your grade or anything for UCC there, okay? But again, if you're interested, let me know. Oh, and fill out that form. Also, course evaluations. Course evaluations are due tomorrow by 8 a.m. So, very soon. Very, very, very soon. And right now, we're actually going to take 10 minutes to complete that course evaluation. The reason for that is, well, one, it's fully anonymous, so whatever you put there, if you absolutely hated this class and you hated the way that I taught it, that's okay. You can talk about that. If you absolutely love the way that I taught this class and love the way that we did it, you can go ahead and put that. Or if you're just in the middle, you're like, eh, whatever, that's fine. Put whatever you want. This is your opinion, and it's fully anonymous. I won't know who wrote what, okay? But the reason why we're going to take 10 minutes now is because if the whole class submits the course evaluations, we will do a 2% increase on the final exam, but only if the whole class does it, okay? We have 3 of 4 people here. So we're getting real close to getting that full class, right? And by whole class, we mean both this section and the other section with Anshul Shah's lecture. He also had an almost full class today, right? So they should, like the majority of them should have already done the course evaluation. But right now, we're just going to take 10 minutes. Okay, I'll put a timer for us. We'll use 10 minutes of our time to evaluate the course, myself as an instructor, and Audrey as a TA. Okay? So, if possible, Audrey and the staff that's in the back, could y'all just sit outside for these 10 minutes, just so like y'all won't have any view of the screens of the students? Okay?
You know, I realized I won't get feedback from the other students.
I know. It's unfortunate. But basically, so the staff is going to step out just so that you can have privacy for your screens, right? I will not be walking out there so that I see your screen at all. But again, if you do the course evaluation and the whole class does it, then we can go ahead and get 2% extra credit on the final exam. Okay? So I'm going to go ahead and put a timer here for 10 minutes. And you can go ahead and do those evaluations. Okay? If you are already done with the course evaluation before the 10 minutes is up, just give me a thumbs up so I can see how many people have finished up. And if we end early, then we end early. We can get started with the final exam review. One last thing, for that course evaluation, for the free response portions, if you could just give detail, so I know the things that I could be improving on, things that I'm doing well. And this sort of information is going to be helpful for me to become a better instructor, but also to provide for my job applications that are coming up in the fall. Okay. 5 minutes have passed. We have another 5 minutes. Two minutes left. 2 minutes left. And give me a thumbs up if you already finished the course evaluation. One minute left. One. Okay. We are at time. Has everyone finished the course evaluation? Thumbs up, thumbs up, thumbs up. Okay, great. Fantastic. So, with that said, final exam is tomorrow. Final exam is tomorrow. Final exam is tomorrow at 11:30 a.m. to 2:30 p.m. So far, I have not received any other calls for accommodations. So, this is the time that it will be, and that is the location that it will be. Typically where you have your labs, or around there at least. So be sure to be there for your final exam, okay, tomorrow. Final exam will be in the same format as the midterm, where it's on EdSTEM, and we can, run our code, things like that. Okay. So, oh yeah, so you already did your evaluations, right? And now we're going to do the final exam review. So we have right here. This is the question that we left off at yesterday. But before we get into this, does anyone have any specific questions on any topic whatsoever that we've covered in class so far that you'd like to cover? Yes?
Can you go over the second code challenge?
The coding challenge? Okay, yeah, second coding challenge, absolutely.
The flip colors thing.
Flipping the color, yeah, you got it. Let's do that. Is everyone okay? We're gonna go ahead and go into the second coding challenge. Once we finish the second coding challenge, we'll go right back to the questions. Okay? Awesome. Great. So, flipping the flag colors. You'll be given a dictionary where each key is a country name and the value is a list of colors that appear in that flag. Our task is to flip the dictionary so that each color is now a key and the value is a list of countries whose flag contains that specific color. Okay? So, here's a list of flags that we can be looking at, right? USA, red, white, and blue. Cameroon, green, black, and yellow. Canada, red and white. Okay? This is a sample dictionary. Then, what we need at the very end is a new dictionary, right? A new dictionary, where now the keys are all the colors that are represented in that dictionary as their own individual keys, and the value will be any country who had that color in their flag. Okay? So, we need to define a function that takes in a parameter, a dictionary of countries and the flag colors. We need to create an empty dictionary to store all the flip results. We need to loop through the original dictionary, okay, and then return the new dictionary. Let's try that. So let's define our function. Our function, let's call it flip flag colors, right? Flip flag colors. Where you have your flag dictionary. Okay, so now we have a function. We have a function that Python can read. What do we want to do next?
I did flip dictionary and then the empty.
An empty.
Really string.
An empty, what data type? Dictionary?
Just an empty string.
Oh, an empty string?
Yeah.
Okay. What did you call that empty string?
The curly ones, like the bracket, like.
Oh, yeah, so an empty dictionary?
Yeah.
Yeah, an empty dictionary? Okay, yeah. So let's call that one result, right? Just to give it a name. And now we have an empty dictionary, right? This is what we're going to give back to the at the end of the function. So before I do anything else, what I'm going to put a couple of lines, right? I'm going to put stuff in between, but I'm going to return my result. I have to return my result because I know that my function has to return that dictionary. Okay? Now all we have to do is build up that dictionary of the results. Okay? We have to build up that dictionary. So, what should we do? One of the things we have to do is we have to look at basically every key and every value inside of this first dictionary, right? So we have to see the country of USA, and we also have to see the list of colors that that flag has, red, white, and blue, right? So how can I look at both the keys and the values of a dictionary and go through all of the keys and values of the dictionary? A for loop. A for loop is great. For, what do we want to put here? We can name it something, right? For something in something else. So before we give it a name, what do we want to loop through?
The country and the color.
The countries and their colors. So how can we do that? We know that we have the countries and the colors, all that stuff right here in flag dictionary. Flag dictionary. We could go through it like this. There's a couple of ways we can go about it. Let's choose right now what way we want to go about it. Do we want to go like this? Or do we want to do like dot items? Or do we want to do just like, let's just do like this, and then we can do dot items later. Okay? I'll show you the difference between the two. So for something in flag dictionary, we need to name this variable something. What is an appropriate name for this dictionary? Again, this dictionary is going to look something like this. What can we name that variable? We can name it anything we want, but country? Country is a great name for that. Right? Again, it could be anything at all. We can name this X. We can name this Ismail. But let's call it country because it's more informative of the things that we're looking for. Okay? So for country in flag dictionary. So now what we do is that we're getting USA, we're getting Cameroon, and we're getting Canada. Fantastic. Right? That's great. So what do we do with this information?
Second for loop.
A second for loop. Okay? We can have a second for loop for
Flag colors
flag colors.
in flag dict country.
Flag dict country. Okay. So do we see what's happening here? First, we're going to go through all of the keys of the dictionary. And because we know, because we were told, we know that every value will be a list. That means we can iterate through whatever that value will be. We can now say for the flag colors in flag dictionary, which is our whole dictionary, at this specific key, the country that we're looking at. So the first one would be USA, the next one would be Cameroon, the next one would be Canada. Right? So we have that. So now we have our country name, USA, Cameroon, Canada, and we also have flag colors for each of those individual countries. Red, white, and blue, green, black, and yellow, red and white. What should we do next? Yes?
If the color's not in your result, then you should add it.
If your flag color is not in result, right? So this is checking to see if the flag color not in result. What does not do again?
It switches to Boolean.
It switches to Boolean. So if the flag is in the result, you get a result. But if flag is not in the result, then you get the result. So is red, the very first thing we see, is red currently in result? Yes or no? Currently, no. So what do we want to do? You said that we want to add it.
Or I think it would be better to add like an empty list first.
Add an empty list. Okay. So you're saying something like this. So if flag color is not in result, you're saying, so my empty list. So you're saying have an empty list somewhere.
Or
Right.
I would like say
Or where should this empty list be?
that should be the value.
Oh, that's going to be the value. Okay, so something like this. Result. So you say we want to add that flag color into this dictionary, right?
Yeah.
So we go flag colors, like this. So you're saying first, have an empty list.
Yeah.
Great. So now this color exists inside of result, red. And what does red currently have? An empty list. Okay, great. We can go about it that way. What should we do next then?
Append the flag color.
We can append the flag color. Result at flag colors, right? So we want to get that empty list and then append to that empty list the color that we're currently looking at. Or sorry, not the color. What do we append?
Oh, the country.
The country.
Yeah, country.
Yeah, my bad. I was gonna put the flag color too. I totally forgot. So what we're looking to do is something like this, right? Red should have a list where we get the country names, not it's the colors themselves again. So now the results of flag colors. First, we're looking at red. First, we make it an empty list. Then we append to that country. Make sense? Okay, great. Yes.
Wait, I think you could unindent line 9 by 1, like tab.
Oh. Okay. Like this?
Yeah.
Okay, great. Why is that?
When you run that line, you know that there will always be a key for what you're trying to append to.
That's exactly right. Okay. So this is the way that we're going to read this. When we first see red with USA, aka result has nothing, our result dictionary has nothing, we check to see if red exists in that dictionary. Does it exist in the dictionary? No. Therefore, we set that to an empty list first. We just say, red, you now have a list, and it's empty. We're not going to put USA just yet, but it's just empty now, right? When we finish reading this line, because this line is outside of the if statement, and there's no else or else or any other stuff, we still have to read this line, this very next line. We have to read it no matter what, okay? And that means flag colors, you know it will be in the dictionary no matter what, because either A, it didn't exist before, and you made it to an empty list, or B, it did exist before, so you don't have to worry about, what am I even saying? Because it already exists, you don't have to worry about whether you're going to get an error here. That's what I want to say. You're not going to get an error with this, because you already know that it will exist no matter what. Great. And therefore, no matter what it is, you're just going to append the country that you're currently looking at. Okay? That makes sense to me. What should we do next? Or are we done?
Call the function.
Call the function. Is there anything that we should do inside the function now? Or are we done?
Done.
We're done. Let's try it out. So, let's use this one, flags. All right. Flags is that. And now we just want to call flip flag colors. Flags. All right.
Print it.
Sorry?
Don't you want to print it?
Yes, you do. Yes, you do. You do want to print it. Thank you. Because right now, if we don't print it, nothing's going to get printed on the console. Because we never called print anywhere, right? But now we are calling print. And we're saying print whatever flip flag colors is going to give me back, whatever it returns. And right now it's returning a result. And a result should be this. Let's check to see if it's that. Let's run that. It looks right, but let me just make it a bit like that. All right, so now we see red goes to USA and Canada. White goes to USA and Canada. Blue goes to USA. Green goes to Cameroon. Black goes to Cameroon. And yellow goes to Cameroon. Exactly what we were looking for. Fantastic. Let's see if it works for other things. Let's add a flag. Ella, would you like to add a flag? What country should we add here?
Japan.
Japan. What colors are the Japanese flag?
Red and white.
Red. Red and white. Awesome. Tyler, let's add a flag.
Ukraine.
Ukraine. Okay. What colors are in the Ukrainian flag?
Blue and yellow.
Blue and yellow. Great. Caesar, let's add a flag.
England.
England. What colors are in that one?
Red and white.
Red and white. Cool. Yeah. Red and white. Red and white gonna get a lot of values off of this, right? Blue gonna get an extra value, and yellow's also gonna get an extra value. Great flags that you chose. I like that. I like the fact that we're not veering too far off, and we're gonna be getting basically the same dictionary keys. No new keys, I feel, right? No new keys. But they should get new values. Let's run that. So red now has USA, Canada, Japan, and England. White has USA, Canada, Japan, and England. Blue has the USA and Ukraine. Green is still only Cameroon. Black is still only Cameroon. And yellow now has Cameroon and Ukraine. Fantastic. That's working great. Let's have one last flag with a different color. What's one more flag that we can probably add? What's a color that we haven't used before? You know what? Very biased here, but Mexico has a lot of colors in its flag. It has green. It has white. It has red. It has brown. It has black. It has yellow. It has, is there anything else it has? Yeah. We're not going to get into those details, but it's also got blue for sure, right? So we should at least be getting a new key here with brown, hopefully. Let's run it. So now red has USA, Canada, Japan, England, and Mexico, right? So that's still counted. White is also adding Mexico here. Blue is also adding Mexico. Green is also adding Mexico. Black is also adding Mexico. Yellow is also adding Mexico. And now we have brown. Brown also has Mexico by itself because no other country has that color. Great! We did it! Fantastic job, all of you. That's exactly how you answer this question. Crazy that I chose a flag at the end that has literally all the other colors plus one more. Almost didn't make it. Almost didn't make it. Thank you, Brown. All right, does that make sense on how we created this program? Okay. I did say that we can do it with, instead of for country and flag dict, we could also do for country in items, okay, using a dictionary method. The only difference here would be the following. We would update this to be items, right? Because it's items, we're getting two things. So we can get the country and the colors, right? And instead of in flag dict country, we can say for flag colors in colors. Okay. That should work. The same. Still works. Okay. That's using items. I love the way that this was made, right? I love that. That's using like specific logic of the fact that you check to see if it exists or not. And if it doesn't exist, you add it before you do anything. Then no matter what else, you're going to add that country to that flag color. I love that idea. It's great. We could have also done this with an else, like if-else statement, right? Where like the if statement would have the same exact thing, right? I'm just going to write it out if we wanted to do if-else. So we can show you two different ways of doing it, right? This is one way of doing it, right? Another way we could have done this is if, here we go. We could have kept it like this, an if statement here, and then else, with the same exact code, the same exact one. And I think this is the reason why Tyler decided, instead of using if else, and putting the same exact code in both the if and the else, because you know you're going to run this line of code no matter what, right? You're going to have to append that country to that color. That's why I believe that Tyler decided, instead of having the same exact code in two different if and else, we could just have the one outside both the if and the else, and we're going to hit that line no matter what. Okay. One last way that this could have been done is like this. That's one last way it could have been done. Oh my gosh, I totally forgot to tell the stats to come back in. I totally forgot. I just heard that it's not there. Oh gosh, that was my bad. My bad. Come back. I totally forgot to get you guys. I totally forgot. That was my bad. My bad. I have already started. I started lecturing. Totally started lecturing. Sorry about that. Okay,
I was wondering if they could do this.
I was in the zone. I'm sorry. Anyways, so these are 2, 3, 4 different ways that we can do the same exact line of code, right? Or like it still works in the same exact way. So if we run that, we still get the same exact answer. So you can see how with computer science, there's lots of different ways to get to the same answer. No two people may have, like 2 people may get the same answer, but not necessarily. But you will get the same exact output, like the right, correct answer. Just different ways of going about it. Okay? Any questions on this second coding challenge? No? Okay, great. Any other specific questions that you'd like for me to go over before I start looking at question 13 and just going down the practice final? Any other question at all? If not, we can go ahead with question 13, continue on down, and then probably do the other 2 coding challenges. Okay? And staff, again, I'm so sorry. That was really, man, yeah. I totally forgot. How long were you all out there?
20 minutes.
Actually, no, probably like 30.
30, 20 minutes after.
30
we probably
minutes?
Yeah, 20 minutes after the time.
After
that
the
you were
time
supposed to
was over.
grab on this.
So 30 minutes.
Yeah.
Okay, I'm
Updating
updating
the
that.
Sorry about that.
The
Sorry.
whole staff who knows.
Sorry. Okay, now we're going to look at question 13. Which of the following statements about the code is true? Okay, which of the following is true? And now we can select all that apply. Okay. Look through these, and we can go through all the options to see whether it's true or not. If you have the answer, please just say A, B, C, D, E, or F. Any answers to this question?
A and B.
A and B. The code correctly iterates through all the pixels, and the code correctly applies the green filter. Do we agree? Or should we add something? Should we remove something? Let's look at it. So, Caesar says A and B. Let's look at all of them. The code correctly iterates through all the pixels. So let's see how it's iterating through the function. Here's our function, apply green filter. For a row in the range of the length of the image. Is that correct? Right? It seems to be correct because we're saying for row, we're naming it row because that's what we think we should name it. And then we're doing the range of the length of the image. Image is again a 2D list. Therefore, when you get the length of the image, you're getting all the rows. So that looks right. Then you do a nested for loop, right? So now you're checking inside of that specific row that you're looking at. For a column in the range of the length of image at 0. Is that correct?
Assuming it's a rectangle.
Assuming it's a rectangle. What if it's a square?
Yeah, it'll work.
Should work, right? Yeah, this looks fine. The reason why this is fine, right, is because we can put that 0 here because images, like by the nature of the way that image files work, should be uniform. And by uniform, I mean like this. An image can be like that. An image can be like that. An image can be like this, right? They're all uniform in that every row has the same amount of columns. And every column has the same amount of rows, right? Whether it's like a rectangle like this, or like a more square like that, whether it's large or small, that's fine. You're never going to get an image that looks like this. You're never going to get an image that looks like that. You need this information for the image. Okay? You never get that. AKA, like this row has like, I don't know, 10 columns. You're never going to get a row that has 7 columns. You're never going to have different column numbers for each individual row. For an image. For an image. Okay? That's never going to happen. For an image. I say that a lot, and I say for an image a lot, because yes, this will work fantastically, right? Because we know that row 0, right? Image at row 0, and the image at row, I don't know, a billion, all should have the same amount of columns in the row. Yes?
For images with like transparency, do you know what like value is used instead of a tuple?
Yes. So the question is, instead of just an RGB tuple value, right? There's this other value called transparency, to see like how transparent is this pixel compared to the background. And the answer to that, I don't know if I have the full answer right away, but the way that I assume that it would be is instead of a 3 tuple thing, so instead of RGB, like this, instead of like that, you would have RGB T, transparency, right? So you can have the same exact color, right? But then just depending on the transparency, you could give this value like anything from 0 to 1, right? How transparent do you want it to be? A percentage, basically. Yeah. So yeah, that's how an image would be if you were to have a transparency report. For full disclosure, for the 8A final, we will not be testing for any of that. No transparency value. But for those of you that are interested, this is likely how you would do it. You have an additional value. Okay, great. So, as I was saying, yes, this works. I would personally say, so that you don't get in the habit of always saying the length of the image at 0, or the length of some 2D list at position 0, or at a fixed position. The only reason why I would say I'm not personally a fan of this is because if you get in the rhythm and you get really used to always putting image at 0, 2D list at 0, blank whatever at a specific row location, then if you're working with a 2D list that isn't uniform, which I think I won't have here. But if you're working with a 2D list that is not uniform, you need to make sure that you're looking at like 4 blank in that new list, right? If you have something like that, you want to make sure that you're looking at that specific row. That specific row. How can I update this so that I'm looking at the specific row, not at row 0?
Change the 0 to row.
Change the 0 to row. Okay? You have to make sure that in the future, if you're not working with images, you're not just putting a specific row number. It's always best, in my opinion, to be dynamic at the row that you're looking at. Okay? Because right now, with image manipulation, we know that this won't happen, for sure. But what about for data processing, right? Like the next step after image manipulation that we've done. In data processing, for data processing, you may be in a situation where the row that you're looking at does not have all the data that you're looking for. It's not ideal, but there is a moment where that may happen. Okay? It may happen. So I suggest looking at the specific row column. That's just my opinion, right? You don't have to follow that opinion, of course, but it's just a suggestion that I would have. Now, so it looks like we are correctly iterating through all the pixels. The code correctly applies the green filter. So the filter is being here on line 5. Is this correctly applying the green filter? Yep. Because tuples are RGB, so G's in the middle, right? The green. We drop whatever was on the red or the blue values. We drop them all the way down to 0, but we keep whatever green value we had before. We make it pixel at position 1. And we know pixel is good because we have it right here. So that one works well. The outer loop should iterate over columns, not rows. True or false? False. Why? Why false?
Because each the columns are inside the rows.
Yeah, the column, in this case, the way that we have 2D lists, right? That's 1, that's 2, that's N, right? We have our 2D list. If you want to go through the columns, right? If you want to go through the columns, you have to go like that, which is not necessarily an easy way of doing it. But I will say, you could, in theory you could, right? You could go column by column. But the reason why this is false is this little word right here, should. You must, right? You must iterate over columns, not rows, right? That's false. You could go by rows and then check columns. You could also go by columns then by rows. It's harder. It's harder to understand in terms of a 2D list, but you could, right? You still could. So that's why I would say that's fine. Right? That's false. What about this next one? This is a red filter and not a green filter. True or false?
False.
False. Because on line 5, we see that if it were a red filter, it would be pixel 0, then the numbers 0 and 0 for the tuple. That would be red, but no, we have a green one. Line 4 will cause an error because tuples are immutable. Line 4. Will line 4 cause an error? No, it will not. Because we're not changing the tuple, we're only reading the tuple. Okay? Then lastly, line 5. Line 5 will cause an error because tuples are immutable. Will line 5 cause an error? Yes or no? True or false? False. Line 5 will not cause an error because this tuple, we are reassigning this reference to a tuple. We can do that, right? Because image at row column is accessing the 2D list. We're not changing any tuple. And we're setting it to a tuple, which again is fine. We're not mutating any tuple. And then you say, what about this? Pixel at 1, are we mutating that? We are not mutating a tuple here. What this is doing is merely looking at pixel, looking at the green value, but it's not changing that green value at all. It's merely grabbing that information and using it for something else. Okay? We're not mutating anything. So the answer is just A and B. Okay? Great. Next. Question 14. We have a puzzle. Oh, we did this one yesterday, right?
Yeah.
We did this one yesterday. Okay. So for those of you that weren't here yesterday, please look at the lecture video for yesterday to get a full explanation on this question. Okay. I think we went pretty in depth on this question, and a really good explanation as to why. I mean, wow. Way to pat myself on the back. A really good explanation of why why the answer is the way that it is. Okay. Anyways, question 15. Assume dictionary A is defined as follows. A is equal to 1, 1, 2, 2, 3, 3. For the following code, what is the data type of item?
Int.
For item in A, int. Why is it int?
Because the keys are ints.
Because the keys are integers. Okay? When we're iterating through a dictionary, like this, for item in A, we're looking at the key type. If these were strings, then the type would be strings. These are not type strings. This one is a type int, so we leave it as is. What if it was 1.1? What would that type be?
Float.
Float. Okay? But for now, this is just a 1. This is just int. Great. Int. Next. We have the same dictionary. Nubs is defined as following. For the following code, what is the data type of item? For item in nums.values. Strings. Why? Because why, sir?
There's like quotation marks. Sorry.
There's quotation marks. Here?
Yeah.
Yes. We're iterating through the values of the dictionary. The values right now are all strings. Therefore, item will always be a value strings in this specific code. Right? So that's string. Great. The code below will cause an error. We have the same nums dictionary, 1 to 1, 2 to 2, 3 to 3. Print nums at 1. Ella, will this cause an error? True or false? Question 17.
False.
False. Why false?
Because it's gonna print out the first thing on the list.
The first thing on the list? You mean the first thing on the dictionary?
Oh yeah.
Yeah. It's going to print out 1, right?
Mm-hmm.
What if I were to do this? Let me just move this over here. Practice final. Reflect on this. Any of these really. Okay. What if I were to do this, Ella? Would that cause an error?
No.
No. What will get printed out?
3.
3? This one?
Yeah.
Not quite. And the reason for that is because for dictionaries, again, we're not looking at positions with dictionaries. Right? This number is only referring to
The first one.
a key. So not the first, like in a position, but is looking for that number 1. So the number 1 does exist here. But what is nums at this key of 1?
2.
2. No, not this one either, because we're not looking at the position, right? This number 1 is not referring to like the first in the dictionary, the second in the dictionary. No. This is looking at specifically a key. This key right here, 1. So because this 1 exists in the dictionary, is going to find that 1 and say, okay, I'm going to print out 1. Right? So that's why this will not cause an error. What about now? Will this cause an error? Yes, this will cause an error. Because again, dictionaries are not about positions. Dictionaries are about keys. And because of that, the key of 1 does not exist here. Right? The key of 1 does not exist here. Therefore, this will cause an error. Okay? What about this? Caesar, would this cause an error?
No.
No. Why not?
Because the key 1 is inside of the dictionary.
The key of 1 is inside of a dictionary. Yes. Therefore, this will not cause an error. But what will get printed out?
4.
4. Right? The string that says 4. But it's because I placed that value for that key. Okay? We could add this value to be anything that we want. Any type. Even if I wanted to do this whole thing as a list, this will still work. Right? Okay, cool. Let's go back here. So, false. This will not cause an error. And this will print out 1. Okay. Next up, question 18. The code below will cause an error. True or false?
False.
False. Why false?
You have a list and you're just appending things to it.
You have a list called reading data error, and you're just appending things to it. What are you appending to it?
Dictionaries.
Dictionaries. Are these dictionaries well formatted?
Yeah.
Yeah, I think so. We have the curly braces on each side. We have a key and value pair for each one. They're separated by commas. It's fine to me. Right? So the code below will cause an error? False. This will not cause an error. Okay? What if I were to do this? What if I did this? Will this cause an error? No, this will not cause an error either. We could still do this, right? There's nothing that stops us from doing this. Maybe it's not a wise choice, right? Maybe it's not the greatest choice to do, right? To have a new key that does not exist in other dictionaries. Maybe it's not the smart thing to do, but it's something that we can do. Nothing that stops us from doing that, okay? Nothing at all. So this would also not result in an error. Great. Next. Which of the following data types are valid keys in a dictionary? Oh, did we do this one yesterday too?
Yeah.
We did. Oh gosh. Yeah. Ints, floats, and tuples. Okay? Because these are all immutable data types. And then, which of the following data types are valid values? All of them. Because the value of a dictionary can be an immutable or mutable data type. Either one is fine. Okay. All right. Question 21. Also, if we cover a question, like if we're going over a question that we already did yesterday, let me know, and we'll just skip it. Okay. Question 21. In an image, the outer list of the 2D list contains columns.
False.
False. What does it contain?
Rows.
Rows. It contains rows, not columns. False. Cool. Question 22. Given the following 2D list, right, we have a grid. The following code will give us the length of each row. True or false?
Both.
False. Why is that, Caesar?
Because you're just calculating the length of the original grid, and it's 3. It'll be 3 every time.
Aha! What you're printing here is the length of the grid. Grid is the whole 2D list. Therefore, this will always be 3. The grid has 3 different values. So anytime you print it, it's always going to be print 3, 3, 3 every time. What can I change here to get the length of each row?
In the print statement, after grid, add hard brackets and row.
Row. Right. Would that work? Oh.
Range, or you have to change range.
You could change it to range. But if you had it like this will still work. Oh, let me show you here. Oops. Grid. Put that grid here. Then we do this. Right.
Oh, length of row.
Length of row. Yes, yes, yes. Okay, so the way that it is right now, it's always going to print out 3, right? Even though it should be printing 3, then 4, then 5. but that's because it's grid. But if you wanted to print out the length of each row, you just do this, row. And the reason why this works is because what are we iterating through right now? For a row in grid, what data type will row be? A list. It's going to be the actual list itself, right? We are not, I repeat, we are not looking at the position here. What will we change here if we want to look at the position? The position of the row. Range. If we wanted the position of the row, aka position 0, row 1, row 2, like that, then you would have to use the range of the length of the grid. And then here you would have to do grid at position row. That does the same stuff that we had before. Question?
Could you also just use the index method?
The index method. How would I do that?
Like grid.index row.
Grid dot index row, like that.
If you had like your old setup.
Oh, like this. Length. Sorry, for ranging grid.
And then you delete your length function.
Delete the length function. Print grid dot index row. Okay. So what this is doing first. So you're saying this should print out the length of each row?
Oh, you would need oh wait, that wouldn't work though.
It would not work.
Yeah,
What will this currently do?
it gets the index.
It's the index, right? 0, 1, and 2. This is a roundabout way of doing the range function, right? So you could get the index of a row like this. It's fine. I suggest not doing that only because what if I had this? What if I had that? By the time I get to this one, it's going to print out 0 again because it's a repeated row. It's a repeated item. And index will only give you the index of the first instance of something that happens inside of a list, even if there happens multiple times. So I would suggest not doing it this way. Right? So, anyways, all that to say, if we wanted to get the actual length of the rows, we just say print the length of the row itself. Because row in this case is the actual list, not the position. Okay? Awesome. Next. How much time do we have? 14 minutes. Okay. 14. Dang, Andrea. Sorry. Okay, so question 23. All of the rows in a 2D list have to be the same length. True or false?
False.
False. Right? Because all the rows in a 2D list do not have to be the same length. They can be like that. Right? It cannot be like this if we're working with images. Let me be clear. If we try to print this out, or like try to show this image as a JPEG file, as a PNG file, all those image files, this will cause us an error. Because the system's going to say, what do I put for these values in the pixel? Like, I cannot show you an image that does not have uniformity, right? But that's only for specifically images, right? For 2D lists, they need not be the same length, okay? What if I did it like this, though? These are not the same length, right? That should work fine, just like we had with grid before. What if I did it like this? Is that allowed? Is this allowed, yes or no? Ella, is this allowed? The way that I had it? Yeah, this is allowed, right? I could name my 2D list whatever I want. I could name it img, aka image. I could name it ismael. I can name it whatever I'd like, right? or grid, which is what we had before. But all of the rows in a 2D list have to be the same length. That's false. You can have whatever lengths you want. You can have empty lists in your 2D list, right? That's totally fine. Next up, question 24. For x in A, B, C, for y in the range of the length of x, print x, y. What will be printed with the following program? What will the following program output?
It should be A0, B0, C0.
A0, B0, C0. The reason for that is because when this x goes through each one of the elements in the list, it'll first be the string A, then the string B, then the string C. The inner for loop for y in the range of length of x, it looks at the range of the length of x. X will either be A or B or C, right, by itself. Therefore, the length of x is always, in this case right here, is always 1. So the range of 1 will just get you the number 0. And that is it. Okay? So when you print out xy, it will print out A0, B0, C0. Does that make sense? Great. Next up, how many pixels does this image have? 9 pixels. 9. Because you have a 3 tuples by 3. So 3 times 3 is 9. All good. I have 10 minutes left. The following code will always give us the number of entries in the 2D list. True or false?
False.
False. Why false?
Because this only works for like rectangular lists.
It only works for rectangular, or what I was at, uniform lists, right? A uniform list, right? This only works for uniform lists, for rectangle lists. Remember, lists need not be the same. They could be like this grid, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each one of these lists is of different size. Therefore, this right here will not always give us the number of entries in a 2D list, because this is looking at specifically that 0. Right? It's only looking at the 0th row. Make sense? Yep. Cool. Question 27 will be printed with the following code. Caesar, what will be printed with the following code?
1, 2, 3, 4, 5, 6, 8, 9, 10.
Yes. 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay? Because for I in range of length of grid, so you're going to look at all the rows, but then for j in the range of the length of grid at 0. So you're only going to read up to the length of grid at position 0, which in this case is 3. Right? So you go to look at position 0, 1, and 2. So you get position 0, 1, and 2 of all of these lists, and you ignore anything afterwards. You ignore the 7, you ignore the 11 and 12. 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay. Last question here. Which of the following is true about this code snippet? Select all that apply. You can say A, B, C, and or D.
B, C, and D.
B, C, and D. Okay? Why not A?
because they point to separate objects.
They point to separate objects, right? The list of 1, 2, 3 for A and the list of 1, 2, 3 for B are two different lists. They hold the same exact information, which is why C is correct. A is equal to B. They are equal, right? They have the same information. That's fine. But they are not pointing to the same exact list, right? So they're looking at different objects. A and B have the same length. They do, because they have the same information, 1, 2, and 3. Length is 3 for both. And if A is equal to B is added to the end of the code, A and B will point to the same object. That is also true. When A is equal to B at the end of the code, so when I do this, right? When I do this, at the end of the day, A will still have a list that points to 1, 2, 3, but now it's going to be pointing to the same list that B is pointing to. Okay? The same list that B is pointing to. One last way to show this is with Python Tutor, of course. If we visualize what's going on here, A goes to one list, B goes to a different list, but if you make A equal to B, A will now point to the same list as B. Okay? Both together. This looks a little weird because it goes up, but anyways. It is what it is. If I had it like that, 1, 2, 3. Okay. Cool. That's the last question on that one. We have 5 minutes left. Any last minute questions, or I'll go through one of these coding challenges? Anything at all? No? All right. We can create flag colors. Oh. So, if we're going to create the flag colors, we have a task, write a function to create a dictionary from an inputted list of lists. So I'm working with a 2D list, right? I have a function called create country dictionary, create country dict, and I have one parameter, country list, right? And what I have to return is a dictionary where the key is the country name and the value is the list of colors in that flag. Basically what we looked at in the second one, that second coding challenge. So how can we do that? First, we need to make a result of an empty dictionary, and we know we're going to have to return that result sometime, right? But then what we have to do is iterate through the 2D list and check to see how we can create it, right? So we know that the position 0 is always the country, and everything after that is the rest of the colors. And what we want is the key to be the country and the value to be that list of colors. So how can we do that? We can do the following. For row in country list, right? For row in country list, what I can do is country is equal to country list, not country list. We're looking at the row itself because we're iterating through the item, the element. So row at position 0 is always going to be the country in this case. How do I get my list of colors?
Row 1 through,
Row 1 through the end, right? We don't know how many colors it's going to have. But we know that it's going to start off at position 1, and it goes all the way to the end. Give me all the colors that are there. If it has 1 color, 2 colors, a billion colors, I want all of the rest of the colors. So we get country and the colors. So how do we add that to our dictionary?
result, country, goes to colors.
Result of country will equal to colors, right? So what this is doing is, it goes through each one of these rows of the 2D list. Using that row, we get the country name, which is always at position 0. And then the colors is just going to be everything after that. Everything after that. so then we create our dictionary. So let's have this piece of code right here. This should output USA red, white, blue, Cameroon green, red, yellow, Canada red, white, Uruguay blue, yellow, white. Let's run that. Ta-da! It works. We get exactly what we wanted. We have 1 minute left. So unfortunately I can't do this last one. But I already have the answer written out. I already have the answer written out for this third coding question. Okay? I'll just walk through it for this last minute. This image manipulation just goes through every 10th column and makes it black. Not a black filter, like straight up just a black pixel. So what I do is, I go through every row, because we don't discriminate against the row, it's going to be for every single row. But for a column, for the column, I'm starting off at, for range, we're going to have range with 3 different inputs here. We're going to start off at 0, inclusive. Then we're going to go to the end of the image, the width of the image, that's exclusive, right? So we never go out of bounds. And then we have a step function. We want to go every 10th column. Every 10th column. That's it. Therefore, every 10th column is going to be this value of column. So first column is going to be 0. Then column is going to be 10. Then column is going to be 20. Then 30. Then 40. Then 50. Then 60. Right? And then we're going to say the image at that row and that column, we're just going to make it black. Okay? That makes sense? On how that works? We can do the same thing with Hopper. Right? It'll work with any image. Oh man, that looks like we're putting him behind jail. Not good. Not good. I know. Canceled immediately. Not good. But it's okay. We can put cats in jail, right? That should be fine. Any dog lovers out there? Anyways. Audrey. So that's the reason why this code here works, right? We're skipping every other pixel, or every 10th pixel, or like we skip by and only look at every 10th pixel instead, right? We skip by and look at every 10th pixel, and that's how you get that answer. Okay. All right, we are now at time. We're 1 minute over. I'm always going over, unfortunately. Sorry about that. But thank you so much, everyone, for joining me for this final lecture of CSE 8A. We did it. And so tomorrow's going to be the final. I'll see you all then. In the meantime, study, relax, and if you have any questions, go to tutor hours, office hours, all those things. I think I'm going to hold an extra